Hello, everyone. Welcome to the second week of our second lecture, lecture number 2, which is cyber attack. This is our third video lecture that I'm recording for you, and we would have two more. This specific lecture, lecture 2, which is about cyber attack, it will have a total of 5 video lectures that you will see in this week, and one for the next week that is also the exam week. So you should have already received an email from me and also the same thing as an announcement on Blackboard that describes to you how you need to prepare for the exam and how are we going to administer the exam. Please read that email or the announcement on the Blackboard carefully and prepare for the exam. What you need to study for the exam is lectures 1 and 2, which is lectures 0, 1, and 2, which is uh, background in computing system and also basic definition of cyber attacks, plus the this current lecture, which is about cyber attacks. So last week we talked about major malwares that we can see in cyber attacks, and we introduced viruses, and also we introduced um, uh, Trojans, we talked about bots, we just named them. And we talked about two of them, which was viruses and worms. And I'm just quickly reviewing what we've said last week. We've said that the viruses are kind of malicious portion of code that they need some type of platform to be installed on it. So when we say virus, it means a malicious portion of code which is going to be attached to a program or a file or a document, whatever. And once the user tries to run that application or that executable file, or once the user wants to modify that document, the virus gets started, the virus triggers and implements the payload or the malicious activity. In contrast, we also talked about worms, and we said that the worms are kind of independent individuals and they don't need any hosting application or hosting file or hosting document. They can kind of rely on their own, and they don't need any hosting file or application. So it means that they can easily travel from one computer to another computer. Most of time, worms, they also exploit network vulnerabilities in order to let them easily propagate and spread over different computers. So this was a discussion that we started. Now we are going to talk about the rest of the list that we've introduced. We talk about we talk about Trojans, different types of Trojans that we will have and we'll see. And also we talk about another type of threats, APT or Advanced Persistent Threat, the current slide that you see. Of course, I changed the order in order to make them better connected to each other. So the order that you saw in the list, I'm not going to explain based on that order. The first thing that I'm going to talk about in this video is advanced persistent threats, and based on that APT attacks or advanced persistent threat attacks. Okay, let's get started and describe or define what are advanced persistent threats and how the attacks based on APT are defined and works. Advanced persistent threats are actually well-resourced persistent application of a wide variety of threats toward a selected target. So here in this is a definition that comes from NIST, and per this definition we have two multiple major kind of features that we see in the definition. One of them is the persistent application. It means that we are using a wide variety of threats toward a selected group of targets or selected group of victims that might be individuals or businesses or organization or even political parties. And we are persistent in, I mean, the attacker is persistent in applying those attacks or those or utilizing those threats. So the feature persistency here is a key. It means that uh, the attacker or the attacker's team, they're motivated, they're determined to implement something malicious on the victim's device or victim side. And of course, again, another feature is selected targets. It means that APT or advanced persistent threats are not defined uh, to infect many peoples or many individuals or many computers. They're defined for targeted groups or targeted victims. So here are more explanations about the terms. When we say advanced, it means that a wide variety of intrusion techniques, or malwares, or threats in general, they can be used, or even in some cases, custom malwares might be defined or might be developed for an APT. And again, when here another kind of part or another aspect of advanced is that uh, the individual components may not necessarily be technically advanced. I mean, this means that uh, the attacks or the threats that are being used in an APT attack, they might not be very advanced. They might be though, but it's not necessarily, they are not necessarily advanced, but they're carefully selected to match the chosen target. This is very important. It means that the attacking side, that most of the time we should say there are more than one person or one individual. There are mainly teams or organizations or sometimes even governments. They have studied, they have done a good research about the victim or the target side, and they know details of their system, they know the architecture of their system, and they select or they pick appropriate threats in the system, or sometimes they develop some uh, malware, some custom malwares for them. So this is why it features the kind of being advanced. And also persistency. The APT threat features persistency. It means that the attacks which are, we will be talking, actually we are now talking about threats, and attacks of course are the next step after threats. If you have threats, you can make them active and you can turn them to real attacks. But either threats or attacks of APT, they're extended over a long period of time. It means that this is not like that I come and I try to attack your computer. I may I may accomplish or I may fail, because the exploit or the vulnerabilities that I'm using, it might be protected or in your computer or might not. So the first try I do might be successful or may encounter a fail. But in most of cases, in other cases, other APT cases, if I realize that your system is secured, I give up. I give up and I'm an attacker. Now, when I say I mean the attacker gives up and goes to and tries a different computer, tries a different victim, because it doesn't matter for attacker, for non-APT, that who is the victim. It doesn't matter. But in APT, the story is different, and it matters who is the different. If my first try uh, doesn't go through, if I'm not successful in my first trial, I try to find another exploit or vulnerability, and I try to change my attack based on that. Or sometimes I try to implement a variety or a sequence of attacks. First, for example, I send you a phishing email that we will be talking about. It's a type of, for example, spam emails, and I try to redirect to a different page, and I get some information from you, and then I implement some impersonation attack, and then after that I try to register something in your computer or download something in your computer and install that program, which is a virus or a worm. So you see, it's there is the key term of persistency here. It means that this is a target that I am determined to attack to him or to her system, and I do whatever I can to reach this goal. If the first trial wasn't successful, I changed my strategy. I try to find different uh, ways or exploit different vulnerabilities. And of course, the level of threats in APT is more than normal threats, more than, for example, what we see or what we feel about worms or viruses, because in APT, we have some features. First of all, APT is most of time uh, organized by more than one person as a result of an organized a team which are capable of doing something, and most of the time they're well funded. They're, for example, they're hired a group of 3 or 5 attackers or experts or hackers are hired for more than 2 years, and they are being paid for 2 years to do something. So it means that the level of threat that we should feel, we should kind of consider from APT is way higher than what we see from a worm or a virus. And of course, active involvement of people. Here again, we have people or expert people that are involved in in this APT project. We can see it as a project defined by someone. This actually active involvement of people or human that are most of time expert make it even more complicated or more dangerous compared to the case that we have some automated attack tools. And for example, you have a worm, and the worm is just a program and doesn't have that level of kind of intelligence or smartness to change the way. Of course, we said that some worms try to use isomorphism or metamorphism to change themselves. Yeah, that's right. But worms are basically seeking or using the same vulnerabilities or the same set of vulnerabilities. They don't have that level of intelligence that we see here in advanced persistent threats. And of course, the threats or the set of threats in APD might be used to implement the attack. The aim of attack is very clear. It might be anything. It might be compromising any of those pillars of the security that we mentioned, stealing the information or denial of service, or putting the infrastructure down, or stealing the data, whatever. That they may even have some physical consequences. For example, if some attackers implement some APT on some power grid components or some fuel distribution systems, there might be some physical disruption as a consequence of that attack. And again, like we said, the techniques used are advanced, and they are a set of techniques. They are not just a single technique. They sometimes use social engineering. We talk about these today. They use social engineering to somehow find a start exploit in order to start the APT. They send phishing emails, and they may also use drive-by download, which is again another type of attack we will be talking about this also today. It means that in a kind of quick introduction, it means that you try to download something on the victim's computer or computers in order to install some viruses or worms on the computer, and then continue the rest of the malicious activities that you want to do. And the intent, of course, is to infect the target system. That might not be one person, might be an organization, or even a party. And yeah, APTs might be also used to kind of as a facilitator for further attacks. For example, once they gain the initial access to the system in the computers of the target organization, further range of attacks or tools can be applied to extend the level of accesses they got, the attackers got, or to expand the kind of harms that they or harms that they apply to the victim systems. So this is APT, and of course, even in APT, we may see at some point that, for example, a virus or a worm is being used after, for example, doing social engineering and sending phishing emails for drive-by download or something. The purpose here might be to download a virus or a worm onto the victim computers. So worms uh, and viruses may fall here, of course, yeah, but the main difference, like I mentioned, is that here we are encountering a situation that someone or a group of person are determined in order to attack a specific group of computers or victim that they are well founded, well structured. They put enough time, more than maybe uh, in the range of, for example, months to years to attack something. So they should be considered as a different type of attacks or vulnerabilities for computer systems. Okay, the next type of malware that we are going to talk about, they are called Trojan horses. I have already gave you a brief description of Trojan horses. It means that you have an application which seems to be safe or normal, but it has some malicious functionality hidden in the application. Here is the definition that we will be using for Trojan horses. It says a Trojan horse is a useful or apparently useful application or program that contain hidden code, and the hidden codes, when invoked, it performs some unwanted or harmful functions. This is the definition of the Trojan horse. And you see that in a few moments that we have multiple types of Trojan horses. Trojan horses can be software Trojan horses, or mobile phone Trojan horses, or even hardware Trojan horses. Uh, but of course, for all of them, we see some type of uh, extra functionality which is hidden, and it's facilitating some type of malicious activities. Okay, how a Trojan horse may work. There are, that I here put it as types of Trojan horses. We may, or an attacker may consider three different ways. The first approach is that a Trojan horse performs its malicious activities in addition to the original program. What does this mean? It means that once the infected application that it has the Trojan in it, it's being downloaded on your computer or the victim's computer. The victim uh, continues using that application because that application is giving the expected services to the victim. For example, you open your Microsoft Word, the Microsoft Word, if let's assume that it has a Trojan horse in the code, and you can use the Microsoft Word in order to write your documentation, modify, edit, save them, print them, whatever. All the services or functionalities that we expect, all the services, they're still available and they're still working. So the user keep working with that application or that program. But of course, one portion of the code written is a Trojan that is kind of doing what the user doesn't like, or or basically is kind of violating security solutions. So this is one of the first approach, and of course, this is the best in terms of uh, keeping the Trojan hidden for a longer period of time. The second approach is this. The Trojan horse performs the function of the original program with some modifications that is malicious activity. It means that some functions of, for example, in our example, the Microsoft Word application, some functionalities has changed. For example, you try to print your document is not being printed, or uh, or instead of printing, it saves something somewhere for you. Of course, this approach might be easier from the Trojan development point of view, because I'm a hacker, I'm an attacker, and I'm developing a Trojan, a software Trojan. In this case, what I need to do is to just find a portion of code which relates to the printing service, and that portion of code, whatever it is, I override my code here, and I put the malicious code here. So this means that this is the easiest way in terms of programming, in terms of modifications that you need to do on the kind of original or clean application. I just override whatever you code, the code originally has been written here. I override my code on top of this, and I just compile it and give you a new version of your Microsoft Word Excel. Once you try to do print, it jumps to the print routine, and instead of printing, it performs whatever I meant to do. And of course, this is like I said, easier. This is easier from Trojan development point of view, but it would be much easier from the user, for the user to detect a Trojan. Because the first time you try to print something, you realize that something is not working properly, something is weird in your Microsoft Word. Probably you try to fix it, or you try to contact someone. And if you cannot fix it, of course, you realize that something is wrong. And one of the kind of options that already come to our mind is that, okay, something is wrong. Maybe I got infected by some virus or a worm or some Trojan, whatever. Yeah, this is one example, a Trojan horse version of a login program that collects password, or a Trojan horse version of a process listing a program. Yeah, here, for example, a Trojan horse version of a listing program. A listing program is, for example, let's say whenever you open your disk drive, my computer, or Finder in Mac, whatever, or you use the ls instruction in Linux, you see a list of files and directories. That's a listing process. A Trojan horse may just change this, for example, to not to show some of the files to you, or show some files that they are not there. They're, for example, deleted, but the infected version of the listing program just artificially just shows them to you, and you feel that, okay, my file is still there, which is not actually, it's being deleted by some other part of the Trojan. And the third approach in developing Trojan is that a malicious function completely replaces the function of the original program. It means that after the, your application got infected, your Microsoft Word, when you open it, you see totally different thing, which is, of course, again, easier from the development point of view. When we come down, we get easier time in terms of coding, and we get easier in terms of being detected. So easier coding means that it would be better for the Trojan developer, and easier for detection means that it is good for the victim system, or from the defense point of view. Okay, what can software Trojan do? They can create backdoor, they can open vulnerabilities for other malwares. They can implement a denial of service attack that we'll be talking about, it, or distributed denial of service attack. They can download some other malwares or maybe Trojans. They can do some game theft Trojan. They can steal information, and they can do ransomware, which means that they show you something. For example, they get some of your file and do not let you to open them and ask for some money. These are all options that a software Trojan may do. Okay, like I said, the Trojan concept is very broad, and it's being used in other domain as well, not only in the software. We have, if you do some research, you see that we also have some Trojans in the hardware level. I'm just quickly going over it. A hardware Trojan is basically a malicious or unwanted modification on a integrated circuit. You buy this chip, and this chip, you're told that this is, for example, let's say, ARM processor, which is being used in many mobile devices now. And how can I trust on this? Uh, does it really match the exact description that mentioned in the, for example, manual or in the catalog that I've uh, received with this device in my purchase, or it may have some other extra components in it. Um, there, if there is some extra component in this hardware, it would be very, very difficult to detect, and it can, since it has implemented at the hardware, at the chip, it can do many different or a wide range of accesses to the system resources. But you may ask that how it's possible. I am I am trusting to the ARM company, or I am trusting to the Intel company, or the other hardware developing company. The problem is, it is not like, for example, uh, 10 years ago or 20 years ago, that when you buy this chip from Intel, everything is being developed and is being fabricated by the Intel itself. It used to be like this 20 years ago. When you buy a chip from Intel or AMD or um, AT&T or TI, Texas Instrument, everything was being developed and deployed by that same company. But now is different. They are using something which is called IP core. It means something like a library function, but library of hardware components. Modern chips, like the chips that now we are using, for example, processors or GPUs or RAM, they have multiple components in them, especially GPUs and processors. And Intel doesn't have enough time to implement all of them. Intel goes and buys some of them as library. So this is one source that Intel may end up having some Trojan in its chip. So this is this part. Third part, intellectual property. Intellectual property is basically that library functions that some big companies purchase or buy from smaller companies, because they just wanted to quickly or faster finish their product. Or all of them, all of these companies, they're using EDA tools. Of course, a product in the size of a processor is not being developed or designed on a paper. There are computer applications like, for example, like what we use to develop software. There are big computer applications that they help design chips. Those tools might be source of injecting hard Trojans into our final design or final chip. And the third option for having Trojans inserted in a chip is the fabrication. Again, it used to be like this, that deployment happens by the Intel, but now companies, they send their designs for fabrication, for making the real chip, into different companies. They're called foundries. There might be one, two foundries that, for example, Intel, AMD, Texas Instrument, many companies, they use them. But what it is, it means that it is outside the Intel. So it might be a source of inserting Trojan at the fabrication time. And all these together, it means that the kind of the hazard or the security alterations of hardware Trojans is something real, and we see it's being started from, for example, let's say 2010, 12, that people are talking about having or observing some types of hardware Trojan in sub-chips. Okay, and the last type of Trojans are called mobile phone Trojans, which is obvious for understanding, and it's kind of simple to realize how hackers, or why hackers are targeting mobile phone or smartphone. Because the rapid growth of a smart market with that rapid growth, we have many people that they're doing a critical application or dealing with sensitive or critical information using their mobile phone. So whatever reason attackers or hackers had to develop any type of malware for computer system, now those motivations and those reasons are valid for mobile phone as well. The most or the kind of one of the most usual ways for developing malware for mobile phone is through distributing some apps through app stores or app marketplaces like Apple App Store or Google Play or other app marketplaces. And basically someone comes and develops some app, the app seems good and it's free most of the time. You download it, it gives you some good functionalities, but at the same time it might be compromising some of your security policies or regulation. And of course, considering the percentage of Apple versus Android devices, many of the mobile phone Trojans are developed for iPhone devices. So I'm sorry, for Android devices. And this is the first Scholar is the first Trojan horse developed in 2004 for Android devices. Okay, the next malware that I'm going to talk about. So out of that list of 5 that I introduced to you, viruses, worms, Trojans, APT, and bots, I've talked about 4 of them. Bots, I'll be talking about them later, but before that, I'm going to introduce you other malwares that they're also important and we need to know them, and they can easily compromise any of those security pillars in a computer system. So the first thing, which is actually a group of threats, is called social engineering threats. Social engineering threats is this is a wide kind of topic, and I'm not going to talk about all social engineering threats and attacks. I picked one of them to talk about it, and when I talk about it, you see that how it's related to society and how it's related to social applications and social networking application and stuff like that. Okay, but in general, this is a definition in general that defines the social engineering attacks. It means, or threats, it means any threat or any attack that tries to trick the users to assist to being attacked. It means that I trick you, I'm a hacker or I'm an attacker, I trick you and I tell you something which is of course not right, and you do something, you take some actions that those actions are against your security. You assist me in attacking you or your computer or your system. This is social engineering. It means that I deceive you. I try to show you something which is in fact not right, which is in fact not true, and I, based on that, try to attack your computer. So you assist me in being attacked. Okay, now let's start and talk about the spam. Spam, I'm sure that you all receive many different spam emails every day. They're unsolicited bulk emails, and a good number is then, even nowadays, we have more than 50% of business emails to be a spam, which is a big, big number. Okay, what spam are supposed to do, they can do multiple, they can follow multiple kind of goals. One of them, which is the safest somehow from the security point of view, is the advertising. Spam emails that just try to advertise something. They try to convince the recipient or the user that some goods or some products are very valuable, they're very helpful, and they try to convince the people that, okay, come and just buy this product. These are called advertising spam emails. And of course, I'm sure that you receive many of them. But like I said, this is the safest from the security point of view. We have some spam emails that they carry some malware. there might be some attached document in them that if you open that email, they expose some vulnerabilities. The attached document may have a virus or worms, may have some virus, might be a worm, or it may carry some Trojan horses. So these are spams that they carry some type of malware or some type of malicious code by themselves. And the third kind of goal that the spam might have is to accomplish or to implement a phishing attack. Okay, what is a phishing attack? A phishing attack means that spam comes and tries to direct the victim to a different place, to a different website or a different application. It might not be always website, it might be even a different application. We direct, or let's say we redirect the victim to a fake website, and in that fake website, the user, for example, starts, the user is being deceived, and the user thinks that, okay, this is my, for example, let's say my bank website, because they designed it exactly similar to for example, a specific bank or that specific website, and from the appearance, the user can barely realize that this is a fake version, and everything is similar. You just put your username and put your password, and that's it. They capture your username and password. So they, or even other information, username and password might be one thing. For example, they can ask for all of your information, and then they try to impersonate. They try to play your role on other on other applications based on the information that they have collected. So this is one thing that they can do. Or they can redirect the user or the victim to complete a form, like I said, to complete a form. And once you complete that form, some personal information are being collected, and that personal information later will be used to impersonate. Impersonation means that the hacker or the attacker try to play the role of someone else, try to show that, for example, I'm John, while I'm not John. I'm a virus, or I'm a malware, and I'm trying to show that I'm John because I have already collected the John's information through a phishing attack. These are three kind of goals, or three types of activities that the spam may do. They may advertise, they may inject some malwares, or they may do phishing. The next thing that we need to do about spam emails is that spammers now, they're being very smart, and they use smart ways to convince you. For example, this is a real example, that a weight losing spam campaign with thousands of fake users or fake kind of subscribers on Twitter. First, they come and they develop a Twitter group, and then they create thousands of fake users. They make it like an active group that everybody posts. They retweet each other, they like, or they reply. And then you receive an email from that kind of links to that campaign. So if you receive something like that and you are interested into weight loss, you go and check the campaign. It seems like a legit thing, and then you follow the links in the spam, and then they may do whatever they want to do. This happened to me personally. Not exact thing, something similar to this. Or another, of course, after if you pay attention to the URLs, one easy way to get rid of this type of thing is that always in your browser, pay attention to the URL. The URL, I'm sure that all of you know, but that's the address bar that says, for example, HTTP column // / something. If you look at that address, that's something that is not easy for them to tamper. So if you see that, it is most of the time helpful because you see the URL, you see the internet address, and you see that where are you entering your information and uh, what's the website that you are now visiting or talking to. And another thing that kind of make spam or phishing attacks based on a spam emails make them difficult or complicated is the fact that sometimes victims uh, they don't know. For example, in this specific example, you have thousands of fake users on Twitter. Out of that 1,000, some of them might be real individuals that they are victim and they have not realized that, okay, this is a fake, this is a uh, kind of scam group on the Twitter, and they share or they uh, promote that group without knowing that. So or even it might be users that they are getting some incentives. For example, um, someone you may receive some kind of email that, okay, if you just uh, become a member of this group, if you subscribe for this group, you'll receive this amount of money. If that's safe, most of people may do it, but your existence at that group will kind of give this feeling or this impression to other people that, okay, this is a legit group, okay, let's follow it, let's follow their link, and then rest of that is phishing. Okay, the next type of malwares that I'm going to talk about is called mobile code. Mobile code by itself is not a bad thing. Other than all of these previous malwares that I've introduced, they're all bad things. But here, I'm talking about something which is basically not designed or not defined for attack. Mobile code per NIST is defined as a program that can be shipped unchanged to a heterogeneous collection of platforms and executed with identical semantics. It means that you write something, you write a code, and that code can be executed on, for example, let's say iPhone 11, iPhone 12, and iPhone 13. That's a mobile code. Or in Android devices, you write a code and that code can be executed with the same semantic on various Android devices. So this is a mobile code, and by itself is a good thing. It means that I'm a programmer, I write something, I develop something. So it is good if I have the option to distribute my application over a wider range of customers. But it can be used to distribute malware as well. And this is a time that makes it complicated. Uh, yeah, it can be used as a mechanism for virus, worm, and Trojans to be distributed, to get propagated. And of course, uh, after that, they exploit vulnerabilities and they perform the malicious activities they want to do. Okay, these are most popular kind of ways of developing mobile codes: Java applets, ActiveX, JavaScript, and Visual Basic scripts. These are the easy and widely used ways that people use for developing mobile code. And most common ways that attackers may use it for malicious activities are here: cross-site scripting, interactive and dynamic websites. Of course, I write something, for example, phishing falls here. There are websites that you need to interact with. You need to enter something, and the website reacts or responds with something. So these are interactive and dynamic websites. And if uh, if I'm as an attacker, if I'm developing some mobile infected code, it would be very easier for me to to inject that code into your system through a dynamic or interactive website. Email attachments is another uh, ways that mobile code may use, and downloads from untrusted site and untrusted software, downloads of kind of unauthenticated applications. These are again uh, the third way, the last way, sorry, that uh, mobile codes may use for injecting that malicious code into our systems. Okay, the next type of malware that I'm going to talk about is called drive-by download. Drive-by download, uh, it is basically the case at which hacker or attacker comes and exploit vulnerabilities in our internet browser or some of the plugins that we have installed on our internet browser. So you are of course using some browser. It might be Safari or Firefox or Google Chrome or Internet Explorer, whatever. Whatever that browser is, there might be some vulnerabilities in them. And if I'm a hacker or an attacker, these are the steps that I can take. I I expect you as a user come and visit some websites. So uh, I wait for you. Before you come, I change or I find some vulnerabilities in the website and put the malicious code in the website. And then once you get connected to that website, I use the vulnerability and inject the code into your computer once you visit that website. Of course, that's through some download. It means that here is this chart. This chart show it actually maybe better. Here, the first step is that the attacker comes or hacker comes and compromise some website. This is a website which is compromised, and some injected code or injected or malicious codes are here in the website code. And then it waits. Then the attacker waits so that the user come and visit that website. And then vulnerabilities in the browser or the plugin will be used to automatically download that infected code into the user program. The key point here is the vulnerability or the malware is being installed without the user knowledge or consent. It means that you don't know, you never know that, okay, uh, something was installed in my computer. And the reason is your browser or some of the plugins in your browser are vulnerable. That's why it is very important not to download unauthenticated or untrusted plugins into your computer. One example is the vulnerabilities in Adobe Flash Player and Oracle Java plugins. Yeah, like I said, plugins are very important and are very easy because the browser themselves, they're being developed by big companies. And there are most of time, there are few vulnerabilities in them. And even if some vulnerabilities are being found in them, the companies, they can quickly and easily patch them. But the plugin is something that you may install it. That's why sometimes it is a mixed attack. The drive-by download is mixed by something else. They first implement some phishing and redirect the victim to some sites, and then a plugin is being installed on your browser, and then after the plugin, drive-by download happens. You go some website, and that website injects the code. And of course, they may be used to facilitate other attacks. So that's why you see other steps here. And step 4, after the malicious code is being injected to the computer, now the attacker can directly interact with the compromised computer and start, for example, leaking information or files or whatever. The key point here for drive-by download is that they do not propagate. Drive-by download malwares, they don't propagate. It means that the attacker just comes and, let's say, for example, they compromise, for example, the, abc.com, the site abc.com, www.abc.com, and this is up to you. If the user or if the victim never visits this site, his or her computer is never being infected. Okay, the next step or the next version of drive-by download, which is a little bit more smart, is called watering hole attacks. In the watering hole attack, the drive-by download is slightly improved and is kind of made more smart. And it works like this, that the attacker comes and kind of attacker researches to find a list of websites that this specific user is frequently visiting them. So what are the websites that you mostly go? Why should I go and try to compromise abc.com? Why not other websites? So if I'm an attacker, I'm really determined to attack your computer, I do a research to see what are the websites that you normally go and visit, which is easy, which is doable through some sniffing. I can sniff your traffic and I can see what are the websites you go. And then after extracting such list, I try to compromise at least one of them, because there might be a list of sites that you go, abc.com, let's say cba.com, I don't know, ncat.com, google.com, and few kind of addresses that you go and visit more frequently. I pick those, and of course some of them might be protected, might be secure enough, so as an attacker I cannot compromise them. But one of them, for example, bac.com, I as an attacker end up compromising it. I inject my malicious code at that, and rest of that is just waiting. I wait for you to visit this website, and now I expect that you will be infected very soon. Of course, here what we see in watering hole attack in comparison with the previous attack is, here we are talking more about targeted attacks. Here the attacker researches the victim's most frequently visited websites or internet addresses. So it's not going to blindly inject the malicious code into some site. It tries to inject the code into the sites that a specific victim or potential victim is mostly visiting. So that makes it even more kind of complicated for detection, from detection point of view. Even the attack code can be customized. If I'm going to attack to a specific person or a specific group of individuals, I can customize the code so that only when they come and visit bac.com, the attack will be done, the code will be injected. If some other people come, they will not get infected. Again, this makes it more difficult to be detected. Okay, the next type of malware that I'm going to talk about is called malvertising. Malvertising is the time that attacker comes or the hacker comes and develops some compromised advertisement. The attacker embeds some malware into some advertisement, and then attacker pays and put the advertisement legally on some well-known websites or on the target website. And then the rest of it is just waiting for the user to come and visit that website. Of course, some of the website that they accept ads, they check the ads code. And so the ad that, which is the infected ad, it might be detected and might be refused uh, by the kind of the website that accepts advertisement. So there are some chance for failing this type of attack, but if it goes through, it would be very easy. You trust on that website, you go say, okay, this is Google trusted, or any other site, it's trusted. But there are some ads that the ads just inject the file, inject the code into your computer, or the ads uh, kind of performs other things. For example, they may redirect to other place and start a drive-by download. Yeah, the malware code which is being injected into the advertisement can be generated dynamically. Again, like watering hole. If the code is being injected, is being generated dynamically, of course, it would be difficult to detect it. It can be customized and for some specific group, and it can be placed on the kind of on the website few minutes or few hours before that specific person or group comes to visit that website. All of these three kind of actions can be taken by the attacker in order to maximize the hiddenness of the malicious advertisement. Okay, let use this term dynamically as the attendance code for today. So use the term dynamically with the same kind of upper all lowercase as the attendance code of this video. Okay, this is the last type of malware that I'm going to talk about in this video. It is called clickjacking. Excuse me. It is called clickjacking, that basically hijack the clicks or the key hits of the user. The way it works is very kind of interesting. This is a legit application. You have a legit application that you normally, sorry, this is the infected application that you don't want to work, but there is another layer on top of that, which is designed similar to some legit application. So what you see is in fact a stack of these two applications on top of each other. They're attached to each other. You see this one, you see this one, the appearance is similar to, for example, let's say your Facebook, but when you click on this button, there is no such button because this is just an image or something like an image. And when you click on this, you are in fact pushing this button. So they use as a multiple transparent layers to trick the user. The user thinks that, okay, it is the user thinks that he's working or she's working with that legit application that he knows or she knows. And of course, it says pay or username, password, whatever, or click here to show some document for you, and then you trust because you feel that, okay, this is something legit. You click here, but in fact, your key strike or your click is being used in a different application, is being transmitted or not transmitted because there is no transmission. You are actually hitting this button, but the only thing is that there is an extra layer that you see on top of the actual or attacking application. This is the attacking application. And here is just a layer that it shows a legit application to you. It is not the legit app, it's completely, it's just the appearance or a screenshot, some let's say type of thing for the legit application. So the attacker hijacks the click, which is meant the user didn't want to click somewhere here. The user meant to click on these, but the click is in fact being transmitted to the attacking application, and this is the way they hijack the attacks. Yeah, the attacker can force the user to adjust the user computer setting. Some menu shows to you that, for example, okay, if you want to change your setting, go here and change your computer setting, and you think that you are changing or you are updating your computer setting, but in fact you are clicking on something that allows that application to send some file somewhere. Yeah, or unwillingly sending you to a or redirecting you to a different website that again might start click by drive, drive by download or watering hole or any other types of attack. And exactly using this similar technique, attacker can also get the keystroke of the user. Every key that you are pressing in a text box and you are feeling that you are entering that information in a legit website is actually being transferred to a different malicious application, and all of your keys are being hijacked. That might be any information, bank account, username, password, or whatever. Okay, this is the last type of a malware that I wanted to talk. The next thing that we will be talking about in the next video of this week is the payload. We have talked about different types of malwares in terms of the way they work, but the payloads, which means that the type of malicious activities that that they can do or they want to do, is still a place that we haven't discussed. The next video, we will be discussing the payloads that may be used by any of these or combination of these malwares that we have reviewed. Thank you for watching this video and have a great day.